interest factor. Okay? So what is your interest factor? So you get your interest factor, multiply with the annuity. Okay? Now I'll use the calculator to find this answer. Okay, how much you get? How much do you get? How much is your future value annuity? How much is your future value annuity? 100 multiplied with 3.15, right? Okay, so we get 315.25. Okay, so this is the answer. Okay, so if you deposit 100 each year, okay, at the end of 3 years, you will get 315 ringgit and not 300 only. Okay, the 15 ringgit is interest. Okay, so this is future value annuity. Right? Now you look at the detailed part. The first year you deposit 100 ringgit. Right? First year. Okay, the first year from year 0 and to year 51st December, there is no interest because you deposit at the end of each year, right? So no interest. Second year, you get interest out of your 100, which is 5%. You get 205. Okay, 100 to 100 plus 5%. Okay, okay. And then the third year, you will get another 5% out of 205, which is 50. When they total up, the principal and interest, you get 350. Okay, you notice that with ordinary annuity, you will not get interest on the first year. Okay, because you deposit your investment at the end of year 1. So at the end of year 1, there is no interest. Okay. Okay, you get 315. That is future value of ordinary annuity. Okay, now how about using Excel? How are you going to do that? Okay, using Excel. Right, if you want to use Excel, you go to the Microsoft Excel. Okay. Let's say this is okay, the present value you put 0. Okay, there's no money deposited at the first year, right? Today, right? So you deposit at the end of this year, right? So 0. K is 5%. Okay, N will be 3 years. Payment 100 per year. Okay, okay. So what you do is that you put future value annuity. Okay. And then you click on paste function, okay, financial, and then what do you do? You click on future value, right? Future value, right? There is no future value annuity. Okay, you just click on future value, then click OK. Okay, just drag this. Okay, and then rate, you just click on the rate here, 5%. Anper is 3. Payment is 100 per year. Present value is 0. Okay. And then this is ordinary annuity, right? Ordinary annuity, you have to put 0, okay, or omit. Okay. You read here, payment at the end of period equal to 0. Okay. Payment at the end of period. So this is at the end of period. So equal to 0 or omit. Okay. Just omit. Okay, you get 315.25. Okay, 315.25. Okay. Okay, that is using Excel. Now let's say if you increase the interest rate, what happened to your future value? You increase the interest rate to 10%. What happened to future value? This is test, concept testing. What if I increase the interest rate from 5% to 10%? What happened to your future value annuity? Increase or decrease? Okay, let's see. Okay, it increased, yeah? Okay, this is 5%. Now what happens if I longer the term of the period from 3 years to 5 years? Okay, it will increase. Okay, right? Because this is the concept, right? Okay, we finish with using Excel. We go back to our slide. Okay, using the future value with respect to annuity tables. Okay, we have done this. We have done that. Okay, so it is actually. Oh no, this is annuity due. This is annuity due. I'm sorry. Before this was ordinary annuity. Now let's say if this an annuity due. Okay, when you invest it at the beginning of the period instead of at the end of the period. Okay, now you look at this question. It says that 100 ringgit at the beginning of each year. So this one you have to use annuity due. Okay, if it says that at the end of each period, that it is actually an ordinary annuity. So it has some differences there. You can tackle the question from there. Okay, the formula for this is actually the same as the future value annuity, except that you have to multiply with 1 plus k. Okay, like that. Okay, it's the same as future value annuity, but with this 1 plus k, multiply with 1 plus k. Okay. Now you get your answer for ordinary annuity, which is 325, right? Then you multiply with this 1 plus k, which is 1.05. Okay, you get 330, which is higher than the ordinary annuity. So conceptually, when you use the annuity due, it has a higher value than the ordinary annuity. Okay, because it actually compound at the beginning of the period. Okay, the beginning of the period has been compounded. Right. Okay, this is 330.96. This is using table. Okay. Now let's see how I'm going to use it using Excel. Okay, if you want to use Excel, okay, this formula, right? This formula that we have calculated before, which is for ordinary annuity. You just click on the paste function, okay, to get this box again. Okay, under type, okay, under type here. See the type here, right? Okay, you have to put 1. Okay, 1 means that it is actually for annuity due. Okay, you put 1 here. Okay, so payment at the beginning of the period equals to 1. So 1. So when you put 1, it will automatically give you the result here, 331. Okay, 331, which is higher than the ordinary annuity. Okay, so ordinary annuity we get 325, right? Ordinary at 315. Okay, and then if you put 1, it automatically change to 331. Okay, so this is the answer, 331.01. Now let's go back to our slide. 331.01. Okay, so this is how are you going to use Excel in calculating your future value annuity due. Right. Okay, we have done the future value. Now we will try to do the present value annuity. Okay, present value annuity. Now, what is the case that we want to find our present value annuity? Let's look at an example. Example, how much would you borrow if you could afford annual payment of 2,000, which includes both principal and interest, at the end of each year for 3 years at 10% interest? Now let's say you want to borrow for the bank. Okay, you want to borrow for the bank because you want to support your education. Okay, your tuition fees and all that, your expenses, you want to go at the bank and then you want to borrow money. And then you assume that you afford to pay 2,000 per year, which consists of how many dollars per month? Okay, about $166 per month. Okay. Now how much you think that you could borrow? Okay. Okay. From this example, actually you will be calculating how much you should borrow. Okay, if you want to pay 2,000 each month, right? Each year. Okay, in first year you will be able to pay 2,000, second year 2,000, and third year also 2,000. Okay, the amount is a series of equal payment. Okay, so but how much is the maximum amount that you should borrow here? Okay, do you have to borrow 6,000? No. Okay, it's actually lower than 6,000. Okay, so by using the present value annuity, you can find your present value amount of that you should borrow from the bank. Okay, now let's look at your present value interest factor annuity table. Okay, look at interest rate of 10%, interest rate 10%, and then N is 3 years. Okay. Okay. So how are you going to find your present value? The formula will be present value annuity equal to annuity multiplied with present value interest factor annuity I, which is 10%, and will be 3 years. So you get 2,000 multiplied with 2.4. Okay. So you get how much? 4974. Okay, 4974. Okay, this is the amount that you should borrow from the bank. Okay, if you want to pay 2,000 for each year. Okay, you cannot say that if you want to pay 2,000 a year, you want to lend 6,000. No, you cannot, because there is some other factors you should consider, which is the interest rate. Okay, so you get 4973.7. Okay. Now let's look how are you going to use the Microsoft Excel in finding our present value annuity. Okay, you just change this one to present value annuity. Delete this one, and the future value. Okay, future value will be 0 because you have paid all your borrowing, so it will be 0. Okay, interest rate is 10%. N is 3. Change this one to 2,000 per month. Okay, then you can just put this a negative figure. Okay, you click on paste function. Choose financial, and then choose PV. Okay, present value. Click OK. Okay, drag this box. Okay, and then put rate as 10%. N per is 3 years. Payment is 2,000. future value is 0. Okay. Type is this ordinary or anything due? Ordinary, so just omit or put 0. Okay. So then you get the result is 4973 here, right? 0.7. Then click OK. Okay, this will be your result. Okay. Right. Any question for using Microsoft Excel? Right. Some of you already ordered to buy the calculators, right? Okay. Anybody order? The calculators has arrived. Okay. Okay. The calculators has arrived. Okay. Now continue on the slide. Okay, we have finished with present value of ordinary annuity. What if that present value, okay, is actually an annuity due? This is an annuity due. Okay, if you want to change it there to annuity due, you just put 1. Okay, figure will be higher, 5,471. Okay, so it's different. Okay, when you use annuity due, the figure will be higher. Okay, higher than the ordinary annuity. Right, this is using the present value annuity due. Okay. Now let's say instead of annuity, you have a series of cash flow which differ from each year. Okay? For example, first year you have a cash flow of 500. Second year you have a cash flow of 1,000. The third year you have a cash flow of 700. So it actually does not have an equal series of cash flow, right? So what we call that is a mixed stream. Okay, a mixed stream. Okay, in this case, if you are calculating the present value of a mixed stream, you actually calculating the net present value, or in other words, we call it NPV, okay, net present value. Now, if you want to use the table, okay, find the present value of the following mixed stream, assuming a required return of 9%. Okay, we assume that the required return or the interest rate is 9%. Okay, for cash flow, year 1 400, year 2 800, year 3 500, year 4 400, and year 5 300. Can I have the okay, action base. Okay, we have a different series of cash flow here, right? Okay, so it is not annuity. So what you have to do, you have to find the present value for each cash flow. For each cash flow. For example, for the cash flow of 400, you find it under present value interest factor, interest rate 9%, and is 1. Okay, you get 0.917. Then you multiply with 400, you get 366.8. Okay, and for the cash flow for the second year, okay, what you do is that you find the present value interest factor, okay, interest rate 9%, and will be equal to 2. Okay, and will be equal to 2. Then you get 0.842 for your present value interest factor. Multiply with 800, you get 673.6. Okay, that is for second year. And for the third year, what you do is that you find the interest factor, which is 9% and 3. Okay, 3 years. Okay, and 3 years, you get 0.772. Multiply with 500, you get 386. Okay, then you continue on to the rest. Then you sum all the present value, you get the net present value, which is 1,904 ringgit and 60 cents. Okay, this is what we call the net present value. Okay? Okay. Any question? Now let's see how I'm going to using Excel. Okay? Use Excel. 48543. Okay, using Excel. Okay, now let's say you have 400. This is here. Okay, 1, 2, 3, 4, 5. Okay, this is cash flow. This is 400, 800, 500, 400, 300, right? Okay, this is your cash flow. Okay, now if you have this, okay, your interest rate K is 10%, oh, 9%, 9%. Okay, then that is the what we need, right? Interest rate. Okay, what you do is that, what do you think you do? You want to find your net present value, right? So what you do is you click on paste function. Okay, you click on paste function, fx, right? Okay, the paste function, right? Fx. Okay, go to financial. Okay, and then what do you choose? NPV. You choose NPV, right? So you can read that NPV is already says there, right? Return the net present value of an investment based on a discount rate and a series of future payments, a negative value, and income positive value. So if it's a future payment, you just put negative. If it is a future income, you just put a positive. Okay? So this one is this is a future income, or you deposit, right? So deposit negative. Okay? Never mind, you just know about the negative or positive. Okay? Now the rate is 9%. Okay? Rate is 9%. B14. Value 1 will be 400. Okay? Value 2 will be 800. Value 3 will be 500. Value 4 will be 400. And then you just tap to give you a value 5. Okay? Is 300. Then you get the result is 1904.75. Then you just click OK. Right? 1904. Okay, is it the same as you are using table? Right? It is the same. Okay. Now, what if you increase the interest rate to 15%? What do you think will happen? The interest rate to 15%, or the discount rate to 15%. What do you think will happen? Increase interest rate. What happens to your present value? Decrease.